There are lots of trig identities. Some you have to memorize, most of them you don't. We're going to start with the basic trig identities. These are the ones that you need to memorize. Now, I have 4 learning objectives written here, but I kind of summarized them into 2 things. We're going to simplify trig expressions and verify trig identities. So use basic trig identities, verify trig identities by rewriting in terms of sine and cosine. Verify trig identities by factoring, combining fractions, multiplying by an expression by 1, or making designated trig substitutions and simplify. So using algebra and these basic trig identities. The difference between an identity and an equation. An identity is true no matter what variable you stick into it. An equation is true for certain variables that you solve for. You can verify an identity by demonstrating that you can start with one side and do some algebra or trig to it and end up with the other side. You solve an equation by figuring out which variables make it true. These you have to memorize. Pythagorean identities. So, if you can memorize the first one, sine squared of theta plus cosine squared of theta equals 1, you can get the other 2. If you take sine squared, and I'm going to write it again just so I can label that one, and divide it by cosine squared, well, then you have sine squared over cosine squared. Oh, that's tangent squared. Cosine over cosine is 1, and 1 over cosine is secant squared, because you have to memorize those reciprocal identities. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. You also need to know the quotient identities. Tangent is sine over cosine, cotangent is cosine over sine. That is sine squared plus cosine squared equals 1. Pythagorean identity that we all memorize and love so very much. We divide everything by sine, then we get 1. Cosine over sine is cotangent, and 1 over sine is cosecant. And I always kind of remember it that tangent and secant are partners. Cotangent and cosecant are partners. Secant is the bigger one, so you have to add 1 to tangent. Cosecant is the bigger one, so you have to add 1 to cotangent. I don't know if that helps you, but that helps me. And you need to memorize the even-odd identities. What helps me with this one is that if you look at sine of negative, okay, we use theta, is equal to negative sine of theta. Looking at the graph of sine, it is opposite on different sides of the y-axis. So the sine of negative over here is equal to the negative of sine of theta over here if it's positive. And that's true also for tangent. As the graph of tangent looks something like that. Cosine, on the other hand, cosine of negative theta is equal to the cosine of theta, because cosine looks kind of like a little parabola. It's 1, and then it decreases, and then it decreases and increases. So cosine, if you have a theta and a negative theta, they're the same. So that kind of helps me to memorize those even-odd identities. So, verifying a trig identity. Work on one side of the equation. Usually it's better to start with the more complex side, because then you can try to simplify it and end up with the other side. Look for opportunities to factor, square a binomial, or add fractions. Noting which functions are in the final expression, so what you're trying to get to. If the steps don't yield the desired results, try converting everything to sines and cosines. So let's start with one. Well, we'll start with a couple. Example 1. We have cotangent of theta over cosecant of theta is equal to cosine of theta. So I'm going to start with cotangent of theta over cosecant of theta. Now, not much I can do with those except to rewrite them as cotangent is equal to cosine over sine. And cosecant is 1 over sine. But I know how to divide fractions. I invert and multiply. So this is cosine over sine divided by 1 over sine, which is the same thing as multiplied by sine over 1. And then I put a nice check mark next to it to show that I have indeed verified that identity. B. Now I have tangent of theta secant theta, and then I have 2 sine theta over 1 minus sine squared theta. This right-hand side looks a little more complicated to me. So I'm going to start with 2 sine theta over 1 minus sine squared theta. Now I look at that and I see 2 sine theta living on top of 1 minus sine theta times 1 plus sine theta. And I look at that and I think, well, is that going to get me where I want to go? And I realize that it is not, because I need to end up with something that has tangents and secants in it. And in order to have tangents and secants, I'm going to need to introduce some cosines. So I'm going to try something else. That's another thing that's not on that list. If you make a try and you see it's not getting you where you want to go, you can either pull out your big eraser or you can just put an X through it. So now I look at 2 sine theta over 1 minus sine squared theta. I'm going to leave the numerator alone, and I'm going to think about my Pythagorean identity. That will introduce a cosine in there, because 1 minus sine squared is equal to cosine squared. Now I can divide this into 2 times sine of theta over cosine of theta times 1 over cosine of theta, because I have 1 sine sitting on top and I have cosine times cosine down below. So I can write cosine squared as cosine times cosine and then divide it into 2 pieces. But I have the 2 hanging out. I have sine over cosine, which is tangent of theta, and I have 1 over cosine which is secant of theta. And now I'm really happy because I can put my check mark there and be done. Okay, there's the pretty answers. And you can see when I typed it up, I didn't make a mistake the first time I tried it. So, wasn't a mistake, it was learning. Practice, try these on your own, then we'll come back and compare. Remember, don't try to start with 1 and make it turn into cosecant times cotangent times tangent. Start with the complicated and try to get to the simple. Okay, these were pretty fun. So we have tangent times cosine. Easy enough. Tangent is sine over cosine. You get to cancel. Yay, canceling is fun. Write cosecant as 1 over sine. Cosine is as good as it gets. Tangent is sine over cosine. Cancel, 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 cancel 1. Ah, fun. The last one I was able to do 2 ways. Maybe you came up with another way, but the first one I thought of was just dividing it into 2 pieces, because I have secant squared minus 1 over secant squared. So secant squared over secant squared is 1, and 1 over secant squared is cosine squared, because 1 over cosine, secant is 1 over secant is 1 over 1 over cosine. 1 over 1 over cosine is equal to 1 divided by 1 over cosine, which is just equal to cosine. So 1 over secant squared is just cosine squared, and 1 minus cosine squared is sine squared. Or you recognize that secant squared minus 1 is tangent squared, and then you treated that as a division problem. And again, you get to cancel, so these are fun because you get to cancel. Sometimes we have to use some algebra. So let's look at part A here. This is example 2. We have sine squared minus 1. And yeah, we're still using theta. Over tangent theta, sine theta. Minus tan theta. And I'm going to take a look at what I'm aiming for before I go too much further. Okay, I know what to do. I'm going to factor this numerator. I have a difference of 2 squares. This is sine of theta minus 1 times sine of theta plus 1. I look down below and I realize, ooh, I have a common factor of tangent of theta. So tangent of theta times sine of theta minus 1. Go away. Leaves me with sine of theta plus 1 over tangent of theta. And then I look back up and I'm really happy because that's exactly what I wanted it to be. Alrighty. Okay, definitely going to start with the left-hand side. I have 1 minus cosine squared times 1 plus cotangent squared. 1 minus cosine squared of x times 1 plus cotangent squared of x. So I'm going to FOIL, see what happens. I have 1 times 1 gives me 1. Outers gives me, that should be a cotangent. I knew they weren't both cosine. 1 times cotangent gives me plus cotangent squared of x minus cosine squared of x plus, oh no, minus, because a negative times a positive is a negative, cosine squared of x times cotangent squared of x. Okay, so I have 1 plus, I have cosine squared This should be the cotangent. Yeah, positive is cotangent, negative is cosine. So cotangent is cosine squared of x over sine squared of x minus cosine squared of x minus, I have cosine squared of x times cosine squared of x over sine squared of x. Yeah, I think this isn't the path I want to take. Let's go back, and I'm going to rewrite this line. 1 minus cotangent squared of x minus cosine squared of x, and that one was the plus one. Yeah, plus cotangent minus cosine squared of x, cotangent squared of x. Because now I'm thinking I want to try factoring by parts. So I have 1 plus cotangent squared of x minus cosine squared of x times 1 plus cotangent squared of x. Alrighty, so this is 1 plus cotangent squared of x times 1 minus cosine squared of x. Well, 1 plus cotangent squared is cosecant squared, and 1 minus cosine squared is sine squared. But cosecant squared is 1 over sine squared times sine squared, which is 1. Now, let's see if that's the same way I did it here. Let's see, I did cosine. Looks like I did it differently here. Yeah, I did it differently here. So, when I did the PowerPoint the first time, instead of foiling, I went ahead and rewrote 1 plus cotangent squared as cosine squared over sine squared. And then I got a common denominator and combined like terms here. So I have sine squared plus cosine squared, which is 1. And I still ended up with sine squared times 1 over sine squared, which is 1. So either way you want to do it. That's kind of fun that I did it 2 different ways. Now, practice. Do it on your own. We'll come back and compare, and we'll see how we do. Maybe you'll do it differently than I do. How'd they go? So first one, I kind of set you on the path because the first little step here was just saying, hey, let's divide this into 2 pieces. So we divided it into 1 over cosine squared and sine squared over cosine squared. But that's secant squared and that's tangent squared. But secant squared is equal to 1 plus tangent squared. Thank you, Pythagoras. And tangent squared plus tangent squared is 2 tangent squared. We're done. Okay, cosine minus tangent. So, Pythagorean identity, Pythagorean identity. Give myself an equal mark here. And then I got rid of parentheses. And then 1 plus 1 is 2. I had exactly what I wanted. Easy enough. Okay, let's try one using even and odd identities. We have sine squared of negative theta minus cosine squared of negative theta, living on top of sine of negative theta minus cosine of negative theta. Equals. So first thing I see when I look at this is I have a difference of 2 squares sitting on top, and I'm going to go ahead and factor that because I like to factor. If I can factor something, that usually leads to canceling, and canceling brings me joy. So sine of negative theta minus cosine of negative theta times sine of negative theta plus cosine of negative theta, all of that living on top of sine of negative theta minus cosine of negative theta. I didn't go ahead and get rid of the negatives in there because that sign was squared, and I didn't want to lose any signs along the way as I was squaring and factoring stuff. But now I have that and that goes away. So I have sine of negative theta plus cosine of negative theta. Well, sine of negative theta is equal to the negative of the sine of theta, and cosine of negative theta is equal to the cosine of positive theta, which is exactly what I have there, except it's written in the opposite direction, and I'm not going to write it in the opposite direction just to put the check mark next to it. There's the pretty answer. Try this one on your own, and then we'll come back and compare. Again, this one wasn't too bad. Remember that secant behaves the same way that cosine does. So secant of negative x is the same thing as secant of x. So we were able to just replace that and then rewrite as sine over cosine and 1 over cosine, and then the cosines cancel. Easy stuff. Okay, so here's some verifying identities again. And we aren't told exactly what method to use, so we'll just start. Let's look at 4 cosine squared minus 1, and we'll factor that. And this is example 4. So I'm not going to write it. I'm going to go ahead and write down 4 cosine squared would be 2 cosine theta minus 1, and it's a difference of 2 squares, so 2 cosine theta plus 1. Oh, that's all we had to do. All you had to do was factor that. Let's look at part B. Yeah, all we have to do is factor that one. We have a difference of 2 squares. 25 is 5 squared minus 3 sine theta, and 5 plus 3 sine theta. So really that was just saying, hey, let's practice our factoring. Let's look at C. Okay, that one looks like it's going to take a little more work. Yay. So I have cosine of theta. Those are both equally complicated. You could start with either side. So just because, I'm going to start with the left-hand side. 1 plus sine of theta. Now, I see a 1 plus sine theta. I think, maybe I should multiply by 1 in a strange way. That's one of our common things that we do to verify an identity or solve an equation, is to multiply by 1 in a strange way. So if I do this, I would multiply by 1 minus sine theta. Now, why would I do that? Because then I would have a difference of 2 squares down here below. So I have cosine of theta times 1 minus sine theta over 1 minus sine squared theta. Well, my goal is to have 1 minus sine theta up top. Hey, I'm making progress. And cosine of theta down below. But 1 minus sine squared is cosine squared. I have 2 cosines in the bottom and 1 cosine up top. So this is 1 minus sine theta over cosine theta. There we go. You could have started from the other side, multiplied numerator and denominator by 1 plus sine theta. Let's look at this last one. D, we have 1 over, yeah, the left-hand side looks more complicated. Let's start with that one. 1 over 1 plus cosine of x. And just because I get tired of writing, I look at this one and I already realize this is an even odd thing going on here. Cosine of minus x is the same thing as cosine of x. So this is the same as 1 minus cosine of x. I want a common denominator. So it's got to have 1 plus cosine of x, and it's got to have 1 minus cosine of x in it. So I'll multiply this by 1 minus cosine of x over 1 minus cosine of x. I get 1 minus cosine of x over my common denominator, 1 plus cosine x, 1 minus cosine x, minus, now I multiply this one by 1 plus cosine x over 1 plus cosine x. So I have 1 plus cosine x over 1 plus cosine x times 1 minus cosine x. Now I'll combine these into one unit. I would have parentheses around 1 minus cosine of x minus 1 plus cosine of x. All of that divided by 1 plus cosine times 1 minus cosine is 1 minus cosine squared of x. I don't need that parenthesis there. Now I'm going to take a peek and see what I'm going for. Okay, I'm going for cotangent and cosecant. So let's see if I can do some simplifying here. Well, up top, this set of parentheses has 1 minus cosine x minus 1 minus cosine x. All living on top of, Pythagoras tells me that this is sine squared of x. 1 minus 1 goes away, so I have minus 2 cosine of x living on top of sine squared of x, which is the same thing as minus 2 of cosine living on top of sine times 1 living on top of sine, which is the same thing as minus 2 times cotangent times cosecant. Yay, it's exactly what I wanted. And here's all the pretty answers. So hopefully you tried those practice problems on your own. Now we'll compare. We start with tangent times sine plus secant times cosine squared. And I want to rewrite it with only one trig expression in it. So I have sine over cosine times sine plus secant is 1 over cosine, and I just stuck the cosine squared on top. Well, I can cancel the cosine squared with one of those, and then I have, actually what I did was I combined them into one unit. I have sine times sine is sine squared plus cosine squared over cosine. I already had a least common denominator. Sine plus cosine squared is 1. 1 over cosine is secant. So again, I wrote them as their reciprocal, as their quotient functions. So cosine over sine and sine over cosine. And then I rewrote secant as its reciprocal, and I took advantage of the fact that secant behaves the same as cosine. So secant of negative t is the same as secant of t, which is 1 over cosine. So I multiplied by the reciprocal, and then I ended up with cosine squared. That cosine canceled with that cosine. So I had cosine squared of t over sine. I got a common denominator of sine. I ended up with cosine squared plus sine squared, which is 1 over sine, which gave me cosecant. I figured I'd need a whole nother sheet to do the last one. So I have 1 plus tangent squared, which is secant squared, over cosecant. I just wrote those down again. 1 over secant squared is cosine squared, so I could have written this as 1 over cosine squared of x. And then you have 1 over gives you cosine squared. Sine squared plus cosine squared is 1. And let's see, I had secant squared over cosecant squared is 1 over cosine times sine squared over 1, because it's 1 over cosine divided by 1 over sine squared. So that became just sine over cosine squared, which is tangent squared, plus 1, which is secant squared. Whew, that was a lot. You can do this. Just don't be afraid to give it a try and get in there and make mistakes. I make them all the time.